lot of types of applications, actually, not just crowdfunding, because you want to know where the funds came from and where they're going to. So the solution is that blockchain makes this funding process safe and secure. Yes.
Fustino diyordu.
All right. So, Hassan, can you mute some folks that are talking if you can? Appreciate it.
Sorry, okay.
All right. Blockchain makes this funding process safe. It offers transparent access globally. So there's no boundaries involved here. You know, this can be done and from anywhere on the planet. Provides a secure, automated approach to crowdfunding, as well as you can define computer code, right, for the terms of agreement. In other words, a smart contract of some sort. And then, you know, providing an atomic transfer. You don't want the funding to go through unless the goal has been met, right, to exceed a certain amount of dollars. Otherwise, everything will go back to the way it was. And that's what atomic transfers are all about. And that's facilitated by the blockchain. Investors raise funds in hopes of success, and they get a return on investment. And it's really a new skyline for many investors is to use this approach for crowdfunding. So, new way to raise funds. And the next issue and area is supply chain management. So any kind of supply chain scenario is a very good one, right, for blockchain. Traditionally, this has been difficult to manage with the overwhelming amount of information in the flow of the entire process. Lots of materials, financial capital, coordination among multiple stockholders. There's a lot of things that are taking place here and need a good solution. So with blockchain technology, this enhances the efficiency and the transparency. In other words, you can track everything from warehousing to delivery. In the old days, you might have a lot of a paper trail, right? Sign-offs, you know, you sign off as soon as something comes off the boat, and then it goes to the warehouse, and then it goes to the manufacturer. Well, you know, data is more interoperable with blockchain, and you can share data, you know, and information a lot easier to suppliers, to manufacturers, to vendors, and it is tamper-proof. So that's another key area. You know, we've already seen just in these two key, examples, decentralization is a theme, and tamper-proof and audit trails is another theme. So those are two things to keep in mind here with the Algorand blockchain. And this establishes trust. Another big area is the gaming industry, and the gaming industry will facilitate gamers. And right now, the state is the gamers are at the mercy of the game developers, right? Players are bound to the developer's server space. Developers, you know, change the rules of the game. Developers hold the power to change or remove items. So you could be spending a month and earning some, you know, points in different aspects of the game. And all of a sudden, it just goes away. So players are merely, you know, licensees is really the bottom line there. So the solution, things like Gods Unchained, right? This flips the script. That particular game actually gives you crypto tokens. And the gamers actually own those assets. So once they got them, they don't go away. They're in their possession. The player is in control of the ownership, the management, the maintenance, and it is globally available. So if you go on a vacation somewhere, another country, or whatever, you can still get at those because they are globally available. And we are going to talk more about crypto tokens and how you can create your own in Algorand in the way of Algorand standard assets. Another area that really is a great solution for content entertainment is the distribution of things like copyrighted materials. And the challenges with the traditional content distribution are it's not a decentralized approach. There's a vault somewhere, you know, with a data store or multiple data stores that have a lock and key on it. And what happens to the centralized data centers with the lock and key? Well, just about every day you hear about a security breach in one aspect or another. So this is really, you know, something that's happening at a higher and higher rate. And this, we really need to address this in the solutions that we're building as developers. Very difficult to determine which artists are affected. A lot of times there's multiple copyright holders, as well as lack of sales transparency. Again, the audit trail, right? There's a lack of, you know, tracking where these funds actually were. You know, for those that are brand new to blockchain, really what it is a distributed ledger or distributed database, you can think in your mind. And basically it's a read-only, write-once database. And every block that's written has a bunch of transactions that are associated with it. And so this block is when you write out the transactions into the chain. And then they have a hashing algorithm between blocks that really detects the tampering, you know, that could take place in a data scenario. So very, very secure and tamper-proof. So the solution here along this area is with blockchain eliminates piracy via content copyright tracking. It's a lot easier to track it once it's on a blockchain. All transactions are recorded in the ledger. Everybody can see those transactions, and then offers a personalized content experience, as well as provides opportunities for seamless payments and transactions globally. So a few other use cases, you can see here, we've got tamper-proof charity organizations in China, for example. They're using blockchain to improve the transparency of social services and tracking of donations. Back, I think about 10 years ago, when one of the earthquakes hit, there was a lack of an audit trail and to exactly to where the funds went to. So charity organizations now can benefit from this audit trail. Voting, boy, we got a big vote going on right now here in the USA. And by the way, if anybody hears of an official winner, just butt right in and let me know. We're all on edge of our seats here to see who won the presidential elections. They're still counting the votes right now. But anyway, you know, this is a tamper-proof approach to creating, you know, a data store of votes. So again, something to consider going forward, and any voting applications you might write. Again, another great use case scenario. And finally, the automotive industry, right? The supply chain visibility and vehicle integrity is built right in. In China, they're actually putting sensors into the engines there that will track the wear and tear of the spare parts, and you know, give you a good readout in terms of what the automobile has gone through in the state of that vehicle. And not only that, it gets better, right? DeFi apps are exploding in 2020. There's over $20 billion of crypto dollars and stable coins floating around. For those that are unfamiliar with stable coins, it's basically an asset that you would build on a blockchain that is tied to a fiat, like a USD you know, arrangement. So one of the big problems with cryptocurrencies has been the fluctuation of the value of those assets, and this kind of like stabilizes it, i.e. stable coins, by tying it more to a real world economy. And examples, lots of Algorand DeFi examples. Now we're hitting a lot of the Algorand use cases here with IDEX and Monerium and stable coins like Tether, USDC, MELD. These are all out there. In fact, you can see a lot more of these use cases up on the Algorand website. Things like, you know, asset block is tokenizing real estate assets. So if you have a large hotel and you want a piece of that hotel, you can get it now. You can invest in it, you know, through those type of solutions. And really the whole ecosystem is just exploding with Algorand. In terms of the technical companies up in the upper left, we're going to take a look at a few of these here today, like Algosign, and you've got you know, a few explorers out there we'll be looking at. But this is what I was talking about. There's a lot of third-party solutions that are being created out here from a technical standpoint. A lot of SDKs out there. You've got not only the ones that Algorand supports, but there's some community-supported SDKs that are out there, like C# and Dart and Rust. So lots of growth here. And then the financial infrastructure, a ton of companies that are really engaging here with the Algorand ecosystem, as well as all the applications now, the solutions that are being built on the bottom part of this slide. It's really not bad, right? For year one of Algorand, we went mainnet back in June of the year prior. We're looking at over 500 companies now leveraging Algorand's platform. We're on 60 global exchanges. There's a lot of wallet providers. We have over I think it's actually, I got up this slide, it's close to 500 ambassadors. Those are like our MVP folks. Hassan's one of those. And if there's any other ambassadors here in the group, please chime in on the chat window. Let everybody know you're an ambassador for Algorand. And, you know, by the end of the year, we're looking at tracking 10 million users on the chain. That's a freaking amazing. So a big success there. So let's take a look at our first demo here, and we're going to take a look at crypto tokens like we talked about. And there's a tool here called Algodesk that is a pretty cool tool. It has both an application manager as well as an asset management functions. So there's a Teal IDE editor. Teal is our language that we use for smart contracts. But here what we're going to show you is our asset management. And the first thing you would see here is a mnemonic. This is, in other words, this is a private key that you can use for sending assets. And so you'd want to copy that off because you may need that to restore your account at some point, or you know, if you get a wallet, you have to, you know, type in a phrase or whatever, and that'll go ahead and reconstitute it. So let's get started. We're going to create a brand new asset here, and let's call this Russ. Give it a unit name of Russ coin. Let's go to a total supply, let's say 10,000. You can have a decimal point there as well. You could say, okay, I'm going to say a decimal point of 1. So that really means the total supply here is going to be 1,000.0. Also, you could specify a URL. And I know some folks that are using this field to integrate with IPFS. So if you have to like point to a large digital asset, like an image or something like that, you can do that through wiring it up this way. And then I'm going to keep all the defaults, but I do want to point out a few of these fields on the bottom here. One of them is a manager address. This will facilitate all management functions, and these are all changeable. You can have the creator has the initial set of these all set to this HGB account, which is your new account that we just created. Also, there's a freeze address. So this will facilitate freezing functions. In other words, the asset cannot be consumed or traded from a particular account. There's a reserve address as well as a clawback address to claw back funds if you need to, maybe in a game or something, you got funds that need to come back. So these are all programmable. These are all available in the SDK. But I'm showing you the visual version of this because this is a very nice tool and very useful for developers if you want to go ahead and start testing assets and using those in your application. So there it is on the bottom. You got the Rust coin created. You've got, it looks like we had the decimal point after those 10,000 with this IDE. So a little bit of a correction there. So it's 10,000.0. You also have, we can open the asset in the browser. I'll do that in a second. But you also have a lot of functions here in the way of sending assets. Modifying an asset would be modifying, for example, who is the manager. So you can assign that to another account. You can go ahead and freeze. Okay, I think we're okay now. All right, so anyway, let's continue on here. Share my screen one more time. And I think, yeah, we got any questions right now? This would be a good time to take a look at our message queue. And see if anybody else is here.
Yeah, go ahead and push on, Russ.
All right, here we go. Next area on layer 1 features. So we'll talk about Algorand standard assets, as well as atomic transactions, Algorand smart contracts, and rekeying. So the pure proof of stake protocol is the first thing we'll take a quick look at. For those that are not familiar with our protocol at Algorand, it provides true scalability. It scales to billions of users. Also provides infrastructure longevity. It's open sourced, and once that is the case, then now you can actually see the logic that's used to create the blocks in the chain, and really have all that source code available to you for whatever reason that you want. Technical flexibility, we've rolled out several releases and upgrades. Really, the users did not know, really didn't impact or have any downtime on that, as well as having ability to create both networks in testnet, betanet, mainnet, as well as a private network that's like a personal network you can do. So lots of flexibility there. Transaction certainty is really huge. This is instant transaction certainty. There's no forks on the blockchain. Blocks are created in under 5 seconds, and that's improving as the time goes on. Right now, this is a very big feature for solutions that you're building, because it does facilitate things like point of sale types transactions, whereas other blockchains may take 10 minutes, right, to go ahead and do the same type of thing of writing a block out to the blockchain. Platform extensibility, lots of SDKs, a lot of third-party tools, community tools, extremely energy efficient. You can run this on a Raspberry Pi, a Node. Also, it's very cost efficient, less than a penny a transaction. True security. So I had a cybersecurity expert in one of my sessions, and she said, the way to kind of simplify how secure a blockchain is basically, what two-factor authentication is, where you have them, whatever the service is, text you back to your cell phone to prove it's you to go in. Well, you kind of multiply that times the number of blocks in the chains, and that is how secure this is. So it really is tamper-proof, and that is a big strength for the Algorand blockchain. So we took a look at creating an asset with standard assets and ASA, create native tokens, as well as what we did here. And then also we want to take a look at, you have the ability to have administrator functions. And so, yeah, so you can create your own token, right? Your own asset, whether it's for a game or whatever, or your own coin. And you can do that with ASA. Also provides asset spam protection, where you cannot have a spammer just automatically sending out assets to everybody on the planet. You have to opt into that particular asset. So more explicitly, the fungible tokens, which we have here, are one type of example asset. This could be in-game points, stable coins, loyalty points, cryptocurrencies fall into that. You also have restricted fungible tokens, and that would be in the way of securities, government issued fiat perhaps, and anything that involves a clawback capability there. Non-fungible tokens would be like in-game tokens. So these are things that are not exactly the same. Fungible tokens are, each token is exactly the same, represents the same exact thing. Whereas non-fungible would be like real estate is a good example of that. You can have a piece of property, a 4-bedroom home, and 2 different sides of the street, and one would be worth more than the other because there are other intangibles that go into that particular home. So that is a good example right there of doing that. And all you do is create a supply of one, and then you would have yourself a non-fungible token. Then we got restricted non-fungible tokens with real estate, once again, ownership registries and regulatory agencies. That brings us to atomic transfers. This is really a great feature. All must succeed or all fail. So in the example on the right, we got person A is going to send 50 algos to person B, and then person B is going to take this concert ticket and then get it back to person A. So this transaction, it all happens or none of it happens, right? So if the person B doesn't receive the 50 algos, all bets are off. If person A doesn't receive the concert ticket, all bets are off. So this is a way of actually doing transaction between parties that don't know each other. And you have on-chain native functions, easy and secure. It's up to 16 transactions you can do in an atomic transfer. The very important point about atomic transfers is you can wrap a lot of other functionality into an atomic transfer, smart contracts, ASA, you know, a lot of capabilities here all wrapped in. I'll talk more about that as we go on. And this guarantees an exchange of goods, and you can combine it with other technologies like I just referred to. Examples of atomic transfers would be simplified expedited settlement statements, efficient matched funding, reduce counterparty risk. You can enable any multilateral trade. Circular trades are a big item, you know, go from 1 to 2 to 3 to 1. Group payments, very popular as well. Combine ASA with smart contracts. You can have instant settlement for complex multi-party asset transactions. And then distributed payments as well. That brings us to smart contracts. So Algorand smart contracts provide the ability to have transaction execution approval language, or TEAL. There is a Python-enabled compiler that compiles the Python into TEAL source code. And there are two types of smart contracts we'll be talking about here. Stateless, which approve spending transactions. And then you have stateful, which is a global local storage capability on the blockchain. The local storage would be on the user or the account level. Global would be available to the entire blockchain, that particular field. Then we get smart contract value in the finance industry, basically trade finance, clearing and settlement, financial data recording, digital identity. These are all big items that provide a lot of value when doing smart contracts. In the DeFi area, you've got escrow accounts can be set up, payments can be set up, credit and lending, as well as stable coins. So these are all big things that are happening in the finance industry, which is probably the biggest use case for blockchain. Algorand accounts. Let's talk about accounts now, where we have standard accounts, multiple signature accounts, and then logic accounts. The standard account, you notice there's a pair of keys there, right? So every cryptographic key pair consists of a public key and a private key. So the public key is available to everybody. That's what you use to receive funds or receive assets. The private key is used to sign off and send assets, and that is private to you. Only you have that particular key. So what this really represents, this slide, is how you sign a particular transaction. You can sign it by a standard account. One account can sign it to send out monies. You can create a multi-signature account. This is like a check that you cash at a bank that has two signatures that are needed in order to cash that check. In that case, the threshold would be 2. And so you would have 2 signers, right, on that, being able to make that legit. Same thing here with a multi-sig account. If you got, here's 3 in this multi-sig account, 3 accounts. And if any 2 of those vote, you would specify the threshold equal to 2. And if that happens, then you can send funds from that multi-signature account out to whoever the transaction would go to, because it's been approved. Similarly, a logic account is a smart contract, and if that returns true in its simplest terms, then that will facilitate the signing. And that is being used more and more in a lot of different solutions. It's also a new feature we just came out with recently, about a month ago, called rekeying. Up until this point, it's been difficult to separate the public key from the private key because it is a cryptographic key pair. And like I mentioned, the public key is used for receiving funds and the private key is used for sending assets. So what rekeying does is it separates those and assigns another authorized address to approve the transactions, in other words, sign it. So on the left, what you see here is basically you've got the paired private and public. you uncouple those, and then you can replace the signing. In this case, this is going to be using a multi-sig. So maybe you're growing from a single signature to a multi-signature, or you want to replace it with a smart contract. And so now you can facilitate that very, very easily. And it's even supported right in the Algorand wallet, which is showed on the left. The way it looks in the data is actually an additional field here called authorized address. So that is authorizing this NFF account to be able to sign off on that particular account or the spending key. All right, so here's the scenario, right? When we're combining layer one features, and this is what we had started to allude to, right? So you have a voting commission, for example, in a voting example with a spending token that goes out. Now, what you want to do is wrap this into an atomically grouped transaction, because you don't want this thing to succeed unless this candidate actually votes. And then the smart contract will determine, okay, yeah, this is all legit. I'm going to increment the candidate vote total, and then that goes where? Into the global state. So now we have several pieces of technology. You might be using ASA to create the tokens. You would be using atomic transfer to do all the transfer work. You would use the smart contract to verify that this is indeed correct, and then you're using a smart stateful contract to go ahead and write this out to global state. Another example would be crowdfunding. If you're considering doing something like a crowdfunding type solution, same type of thing. You start out with a stateless smart contract that will issue the payment from escrow to the user. Again, you're going to atomically group this, and then user one claims the escrow funds via a stateful smart contract. So here we're combining stateless with stateful. We're also doing atomically grouped, and we're using, we could use a payment, could be any form, right? It could be algos, or it could be assets that you could be sending here in this scenario. All right, we got any questions worth sharing here with anybody? All right. All right, so let's go ahead and continue here. We got Algorand developer stuff. That's the best part of the session here today. So you got protocols and different versions that are being used, and typically new protocol versions would be facilitated through BetaNet testing. And so that's what the purpose of BetaNet is. Testnet and mainnet mirror each other. So if you write an application, you test it out with testnet, you have exactly the same environment on mainnet, same protocol, same release. Then you also have private networks at the bottom, like I alluded to. This is like a kind of like a personal network that you can create for whatever reasons. That is can replicate any one of these particular environments. So give you an example of that. Whenever BetaNet is in flux and we have a lot of rapid changes coming out in a new protocol, sometimes I like to test one out. So I'll basically create a snapshot of that in my private network. And this way, if BetaNet does get updated from underneath, it will not affect my testing. I have a solid test base. So that's a good use case. All right, so then we get the developer portal, and we got developer.algorand.org. So let's go ahead and take a look at that. Or that just happened D and it comes up. How about that? Lots of great content. Here's an example, digital exchange a contract, a DEX application. Here's another one, how to get started with Android. So these are kind of the recent ones we showcase here on the left, but on the right, on the left side, you can see the different categories. We got tutorials, you've got solutions. There's some of the tutorials that are in here. You've got some solutions. Crowdfunding, right? There's a solution on the crowdfunding application. There's another one down here on the voting. I wrote one here on how to build a iOS app with Android and for Windows, and that's using the C# .SDK and Xamarin. By the way, that C# SDK, I believe, just got updated today for version 2. So that's another thing I got to check out and test. And then also you have articles that get published all the time. So we have a lot of great, like here's an article on connecting web apps using Algosign, like I just showed the demo on that. The documentation is the key thing I want to show you here. So when you want to get started going, this is the section you want to go to. You want to start the building. You want to do this workshop, workspace setup, connect to a node, and do your first transaction. So very, very step-by-step oriented. You should be in good shape, and then explore features is another area.